to our webinar on securing your cloud infrastructure with AWS. My name is Stephen Creedon and I'm a solutions engineer here with Tynes. This is the first webinar in a series of 3 webinars where we will be discovering how we can leverage the power of Tynes within your cloud environment to secure access and reduce costs. Just a little bit of housekeeping before we begin. If you do have any questions as we go along today, please go to the LinkedIn event in your invitation and you can drop any questions in there and we'll get around to answering those questions at the end of the webinar. In today's session, I'm going to dive into 2 workflows, the first of which will look for inactive or unused AWS IAM user accounts. If we find any, we're going to automatically create a ticket with the details of those users, and we can then take input from an analyst as to which accounts we want to deactivate. The second automation will cover off EC2 instances that have been left running. This obviously incurs costs and waste resources. The workflow surfaces this information and allows an analyst to terminate those instances if no longer necessary. Before we start looking at our automations today, I just want to do a very quick level set for those of you who are not overly familiar with the Tynes platform. Tynes is a no-code, low-code automation platform. It is completely vendor agnostic. At Tynes, we want to empower frontline analysts to automate manual, repetitive tasks quickly and easily. Tynes can interact with any application that uses an API by simply dragging and dropping one of the 7 action items. The workspace, or storyboard, is divided into 3 separate sections. The left-hand column is where our 7 action items live that we will use to build our stories. We also have over 5,000 pre-built templates which we can leverage to integrate with all of the applications in our application stack. We also have a link to our story library, which contains over 500 pre-built workflows, which you can import directly into your tenant and get up and running incredibly quickly. The main body of the screen is where we're going to build our stories. And the right-hand side of the screen is where we display information either about the individual action item that we're working on or the overall story itself. So let's get started. Let's look at our first workflow, and I'll explain each of the action items that we're using as we see them pop up within the story. So as I mentioned, our first story today is going to look at inactive or user accounts in AWS that haven't been used in a while. 30 days is our suggestion, but obviously you can change that limit quite easily within the story. Our story is made up of different action items linked together. And these action items are simply dragged and dropped from the left-hand side of the screen and linked together by dragging the arrow at the bottom of the action item. The blue action items are called HTTP requests. And a HTTP request within Tynes allows bidirectional communication. And what I mean by that is that it can go outbound and hit an API endpoint and import information. Likewise, it can go from inbound to outbound and push information. So when we create a ticket in Jira, in ServiceNow, whatever your ticketing solution of choice is, we're going to push a JSON payload to standardize the format and the content of that ticket. So let's use our first HTTP request as an example. If I drag the right-hand side of the screen, we can see the AWS endpoint that we're hitting here. We can see the method that we're using. So in this case, we're getting information from AWS. As I said, if we were pushing information out of Tynes, we might be posting or putting. Since we're dealing with APIs, we're obviously going to be concerned around credential and credential security. You can store all of your credentials within the Tynes platform. They will be encrypted using 256-bit encryption, and they will never be displayed in plain text at any point throughout your workflow. So if I click on my AWS credential down here, we can see that there is a credential stored, but we can also see that it's fully redacted. It is never displayed, as I said, in plain text. And we can limit who can see this credential and who can use this credential by using teams within our Tines platform. I mentioned at the start that Tines is a no-code, low-code automation platform. That does not mean we're limited in any way. So in this case, we want to hit our AWS endpoint, but we want to pass across some values in that API call as well. In this case, we want our action to be list users. We want to specify the version, and we're going to set a maximum of 5 users. This really is for just demonstration purposes. In a real-world production scenario, you want all of your inactive user accounts. I just don't want to create 50 tickets within my Jira environment. Probably wouldn't be too positive from my colleagues. But this is just to show that we can pass across lines of code. In this case, it's just a very simple JSON key value pair that we're passing across. But as we get more complex, we can pass across objects, we can include arrays of information. You're really limited only to your own imagination and to what the API will support. The next action in our story in here is called an event transformation. And an event transformation action within Tines is critical to massaging and manipulating data. In this case, we literally just want an array, a list of users. That's all we're doing at this point. So it's a message-only mode we've got our event transformation set to. However, if we have an array of information, we may want to explode out that array into its individual elements. We can then use the explode action. On the flip side, we may want to implode a number of different variables into an array. Obviously, we use the implode. We can deduplicate. So if you're dealing with IOCs, for example, there's bound to be an amount of duplication in what you ingest into your workflow. To save resources, to save time, you can deduplicate based on those IOCs and concentrate on the unique events. We can also set a delay. So maybe you're enriching an IOC with a public threat intel platform. Sometimes it can take a few moments for that information to completely render. So what we can do is we can set a delay, or maybe we're waiting for interaction from an end user or an analyst. We can set our delay on number of seconds, number of minutes, etc. Wait for that interaction to come in before continuing the story. As with all APIs, sometimes they generate a lot of information, a lot of hits onto an endpoint. We can also throttle calls to an API. So instead of hitting an API 1,000 times a minute, we can say, if it gets beyond 100 hits a minute, let's just throttle, let's back off for a little bit, and then hit it again at a later point. The green action item within our workflow represents logic. So the idea of a metric coming in, and we maybe want to split off our story into separate legs and take separate actions. In this particular instance, what we've got in here is a pagination loop. Because if you think about your own AWS environment, you may have one page of users, you may have potentially hundreds of pages of users, depending on the size of your organization. And in an API, those users are listed in different pages, which may vary in length from 10 to 50 to 100, etc. As regards how we process that information within Tines, we're going to use a pagination loop. And this literally just says, are there any more users coming in to this action? So the information will come in from our compile users, and it will then check logically to see if the value is true. It is true if there are other users. It then, again, hits the AWS endpoint. We also check in here if we have one user or more than one user. Because if we have just one user account, we're going to build an object based on that one user. if we have multiple user accounts, we're going to build an array of those users. We're going to compile them either ways. And we can see now a little bit more complication within our action item. Whereas in the original one, we just had a message only mode, and all that was doing was getting our user accounts. But the great thing about our event transformation actions is that we can actually massage and manipulate that data really easily within the Times platform using the inbuilt functionality in the platform itself. And these are kind of similar to the functions that you probably use at the moment within Excel. It allows you to kind of encode, decode, capitalize, you can chunk arrays. There's a ton of functionality in here that allows you to massage this information. This particular case, we're just flattening the array. We're concatenating. If we have one user and multiple users, we're just tacking that one user onto our array. And then we're obviously breaking out of our loop as well. The logic in here is, have we got all of our users, or are there more? If we've paginated through correctly, it will return false, and we can then go on with the main body of our story. Now, the main part of this story is generally just using those 3 action items. We have the HTTP request, the logical trigger, and the event transformation. Walk through the rest of the story. But just to point out at this point, we have a receive and a send email action as well. These are pretty self-explanatory in that send email, if you maybe want to communicate with an end user or an analyst on the outcome of a story. So a really good example would be a phishing use case. An end user submits an email. We use Times to investigate all of the URLs, the IP addresses, the attachments, and then at the end of our story, we email that end user with the results. To kick off that automation, we may use the receive email action. What that allows is use of the Times magic inbox that basically allows an end user to forward an email into this inbox, and then we can start that to kick off our story. We can obviously integrate with Office 365, with G Suite as well. So no matter what your mail client of choice is, we can integrate with that platform, we can ingest information and use that to kick off a story. The last 2 actions, very quickly, the webhook action is literally sitting passively within a workflow, waiting for information to be passed into it. And the send to story action item introduces the idea of reusability. So it's similar to a process or a procedure or a function in any other programming language, in that we can create our various steps of a sub-story. We can push information into it, let it do its thing, take the information back into the parent story, but we can send information into that sub-story from multiple different parent stories. So instead of having to write or create a workflow each time you want to, say, investigate an IP address, we can have a little threat intel sent to story. So from any of our parent stories, we can call that sub-story to investigate. Okay, back to our workflow. So the next thing we're going to do, once we have got that list of users in an array, is we're going to explode them out into their individual elements. So again, we're using our event transformation. We're using explode mode. We're calling our array. And what I'm pointing out here is what we call a pill or a slug within Times. It's basically a dynamic reference to a piece of information that's come in to a previous action. So in this case, once we've built our array at the start of this particular workflow, we're then going to call that array and explode it out. Now, if I click on this at the moment, you can see the value is null. That's because I haven't ran the story yet. We'll see in a few moments when I run the story, this will populate out a list of users in my AWS environment. We're also going to loop through that list of users because we have to go back to our AWS environment and figure out exactly when that account was last used. for all of the accounts. And that's what we're doing in here. We're basically hitting our AWS endpoint. We are delaying for 1 second. We're then going to have a little bit of logic to see if we're still processing those user accounts. If we are, we're going to hit the get service last access details API endpoint again, and loop through and obviously break out of that job once it's complete. The functionality we're looking at this point of our story is looking at when that end user was last authenticated, because in this particular workflow, we want to figure out who hasn't logged in within 30 days. And that's what our logic is doing here within Tines. It's literally setting a counter in this case. So we originally looked at a pagination loop, and that loop broke out if the word false was returned from AWS. In this case, we can set a counter in here. So you can loop through like you would in any coding language. You normally set a loop, you set max value, you increment your loop, and then you break out once you've reached that max number. That's exactly what's happening here as well. It's just that you don't need to be a coding expert to link together your actions and then simply drag your link around to the top again. That's all that's happening in here, is we're looping through to find the highest number in an array, and then we're breaking out once we've got no more logins. The logic in here is getting today's date. So again, this is one of the great functions that's built into the Tines platform, is the date function. It's literally looking for our date. So any time that you run this story, it will use that time and date. It will go back 30 days in this case, and it will then find anybody who hasn't logged in after that period of time. So we are looking for today's date minus our normalized date, which is 30 days ago. And we are comparing that to this large number of seconds, which is 30 days in here. As I mentioned, we are going to create a ticket with that information. Now, in this particular instance, I'm using Jira as an example. Other ticketing and case management solutions are available. Some of the most popular ones, ServiceNow, Jira, as I mentioned. We integrate with any ticketing solution that has an API. Recently, we've introduced our own cases platform that's directly integrated with Tines, so you can leverage that as well if you wish. I'm just using Jira as an example today. So again, like our AWS call earlier on, we are using a HTTP request to hit our Jira endpoint. We're going to create a ticket, and we're going to standardize the layout of that ticket as well. So it's in our particular project. We have a summary in here, but as we go along, we can update that ticket as well. So we call the ticket that's been created, and we start adding information. We start enriching the information. There's not a huge amount of enrichment going on in this particular case. But one thing that is quite interesting in here is the idea of a prompt being added to the ticket. And what that represents is the ability for an analyst who gets this ticket to interact with our story. So we'll see in a couple of minutes a list of AWS users that haven't logged on in 30 days. I know one guy is gone traveling the world, so I don't want to get rid of his account. I know he's back in a couple of weeks. There's another person that's left the organization that I'd completely forgotten to deactivate. So giving that empowerment to the analyst to interact with the story is incredibly important, because we're not about replacing people by using automation. What we're about is rooting out false positives, about serving critical information in a format and in a place and in a time where our analysts can ingest it easily and make a decision. So whether that be a ticketing solution such as Jira, whether it be an instant messaging solution such as Slack or Teams or whatever it happens to be, we serve up the information that needs human interaction. We can use the logic within our workflows to disregard the low priority or false positives if we need to. So if I run my story, it will create the ticket, but it will pause at this point of the workflow. Our next action is logic. It's a trigger to see if the analyst clicks the prompt, which would return an event into our story with the word deactivate. So we're using our logic in here to do a match on a regular expression. This really depends on what you're checking for, what your logic behind the workflow is. So you can use the standard greater than or equal to or less than or contains. If you want to use regular expression, if you're a fan of regular expression, you're probably the first person I've ever met to be a fan of regular expression. But we can actually leverage the power of regular expressions in here to get granular with our logic as well. And we can have multiple lines of conditions. It's not just a very simple does A equal B. We can have multiple conditions, and we can set a must match option in here as well. So if we have two conditions, it must match one of them for the logic to flow through that level of the story. Or we can keep it very basic and say, does the prompt status match deactivate? Okay, if it does match deactivate, well, guess what we're going to do? We're again going to hit the AWS endpoint. We are then going to attach that user to a deactivate or deny all policy. With every workflow, it's best practice to take a note or to update the ticket where you're actually storing this particular workflow or this particular action. So in this case, what I'm going to do is I'm going to add in a comment back into my Jira that we've added that user. But just to be on the safe side, what I also want to do is I want to update the ticket saying the user has been deactivated, but also give the analyst the option to reactivate the user. So maybe I deactivate that guy who's traveling around the world and I go, oops, shouldn't have done that. I need to reactivate him very quickly. I don't need to go back into AWS, log in there, all that kind of stuff. I can simply, from my Jira ticket, reactivate the user. It reverses what we've done. It detaches them from the deny all policy, and it will then update the Jira ticket with that particular action. So again, everything that the analyst does, every interaction the analyst has with the story is tracked within our Jira ticket. Okay, cool. That is by way of explanation. It will make a lot more sense when we run our story. So to run a workflow within Tines, you have two options. You can do it manually by simply clicking the run button, but you can also schedule your workflows to run on a recurring basis. So maybe once a week, we want to run this story. Simply set that to run Monday morning, 9 a.m. When you're building your workflows, you can also test the stories. So again, that's really handy for, just maybe say hitting an API 100 times while you're testing. Just test based on a previous event. And again, you can kind of build safely like that. For the purposes of today's webinar, I'm simply going to run my story. And when I run the story, you'll see these numbers appearing on the actions. And these represent the JSON events in the particular story. So if we come into our first action where we hit the AWS endpoint, we can extend the events at the bottom of the screen, and this will list all of the users in my AWS account. As you can see, there's one in here. Not sure that's a real person, but we can see the structure of the JSON payload. It's almost like that waterfall structure. We can see an array of information in here. So each user is an element of that array. And this is kind of a typical JSON structure that we might see. It's a mixture of key value pairs, objects, arrays, etc. As I mentioned, we are going to compile our users using the event transformation. We're going to paginate. We're going to go through those pages. And since I've limited it to 5 users, that's probably just one page in fairness. But what I want to do then, once that information is out, I want to explode my user accounts out. And whereas previously we can see 1 and 2 events coming through the workflow, when it gets to the explode action in here, it suddenly jumps up to 14 events. And the reason for that is that we had an array. Within that array, there was obviously 14 elements, and now we've exploded each user out into their own account in here. So we can see all of those listed in our workflow. We're then going to check to see the services that they've used when they were last accessed. We can see the last authentication for those accounts. So again, we drag it up. As the workflow is going through, as the story is running, every single action and the events associated with those actions are available to us to look at and to view. And these kind of give us the idea of almost like global variables within any other coding platform, in that at the very end of the story, we can reference the actual first action within our workflow itself and the information included in that workflow. One thing I do want to point out as well, if we come down to our 30 days since last account, I mentioned the idea of pills or slugs earlier on, that idea of dynamic information coming in from a previous action, and then we can either use that in logic, we can use that to populate a ticket, etc. Let's have a quick look at the comparison here to see 30 days since last account used. Again, this is our logic, our trigger in here, and we can see we're pulling in the last time that password was used, which is coming from the events above. It's changing that into epoch time format, and then it's taking that epoch away from today's time and date, again in epoch format, by simply using the date and the minus functionality. And we can see then down at the bottom right-hand side of the screen, it gives us almost like a sanity check. It shows us the result of that logic. And obviously, 1004 is not greater than or equal to 30 days. So it would then disregard that. As regards creating our ticket, as I mentioned, the ticket is now being created within Jira, but our story has stopped. So we create the Jira ticket using that information. We include our prompt, and what the Jira ticket looks like if we come down, oops, and if I went to the right action to see the actual Jira number, we can copy this across, go to our Jira environment, and we can see this is now the standardized layout that we've brought across from our Times workflow. And this can be completely customized, obviously. We've got really nice pre-built templates to create tables within Jira, which is a nice way of surfacing information. But any other information, any other functionality, actions we take can now interact between our Jira ticket and our Times workflow. So it shows us the user account hasn't been used in the last 30 days. I'm going to deactivate this user account. Gives me a message thanking me for taking that action. If we scroll down, it updates the ticket automatically with that action. If we go back to our story, we can now see that the logic has passed through the deactivate trigger, added that user to a deny all policy, updated the ticket with that particular action. But as you remember, it also gives me the ability to reactivate that user account as well. So what I'm going to do is I'm just going to reactivate this user. Again, thanks me for my message, updates the ticket, obviously telling me that this guy has been reactivated on this time, on this day, and our story completes. So that is our first workflow today, our ability to clean up inactive users within AWS. This is available obviously within our story library. So if you're interested in giving this one a go, feel free to go to the story library. You can import it directly into your tenant, plug in your AWS, your Jira, or your ServiceNow credentials, and you can get up and running incredibly quickly. Okay, let's look at our second use case today. And our second use case is concerned with the idea of spinning up EC2 instances, perhaps for testing purposes, and potentially forgetting to shut them off, which obviously is a pretty big waste of resources if they're left on for a long time. But more importantly, will end up costing us money. So what we want to do within this workflow is give end users the ability to spin up an EC2 instance for a specified period of time, to then automatically shut down that EC2 instance, and to give somebody the manual ability to shut down the instance if perhaps they finish early with their testing. So again, our workflow is relying on the HTTP requests and event transforms that we would have seen earlier. But one major difference in this particular workflow is the fact that we're leveraging pages within tines. So pages within tines represent a web front end, basically, that we can surface either to people within our organization or people external to our organization. We can allow them to input information into that web page. We can also surface information to those people. And that's exactly what we'll be doing within this workflow. We will be asking our users of this application to select an instance they want to power on. We'll then surface a message telling them it has been powered on. And obviously, if it's powered off, etc., we can surface that information as well. Very quickly, just to show you what the building of a page looks like, this is one that is already built, obviously. It's a very basic page in that all we have is a nice little image with some logos on it and a submit button. But you can see on the left-hand side of the screen, all of the input types that we can accept from an end user. All of the inputs that you would expect on a normal web page. Short text, long text, URLs, numbers. You can even ask for people to upload files. So again, you could upload a file, ingest that information within that file into a Tines workflow, and use that to kick off an automation. As regards the type of information we can surface to the end user, again, you can see the elements up here on the top of the screen where we can expose tables, images, maps, whatever it happens to be. A really, really cool feature of Pages, however, is the ability to create a theme. And if you think about it, if you have a web application, you're going to have a similar theme running through the entire experience from the end user's perspective. You can create that theme on your first page, and then you can select that theme for all subsequent pages in your web application. So it looks really seamless and smooth. In my particular workflow, we're starting with our start page, submit button to kick off the workflow. The end user will then be given two options where they can search based on the actual name of the existing EC2 instance or search by various different tags associated with our devices. We have logic in here that will search AWS by name or by tag, depending on what's been chosen on the page. We're going to check, firstly, if those instances are currently running or currently stopped. And as you can see, the pages are exactly the same from a throughput of information perspective as any other of the action items that we've covered so far today. So depending on the interaction from one page, we surface different information on a new page further down the workflow. So what we should see in a normal use case is we choose an instance that is not running, it then surfaces that onto a web page, and it says we're starting. So it will take a few moments, obviously, to boot up the EC2 instance. We'll have our delay in here of 5 seconds, and that will obviously loop around until the instance is running in AWS. And once it is going to tell us that, it will surface that information on a results page. But what we're also going to do is we're going to send a message into Slack. This could be Teams, it could be GChat, whatever it happens to be. And this message might either go to the end user who requested the EC2 instance. It might go to an analyst who has a high-level overview of all of the AWS environment. It can really go wherever you choose it to go. Okay, so let's go to our page. If I scroll all the ways back up to the top, and we're going to use the visit page function in this case. And as we can see, we have our nicely branded entrance page. What's happening in the background now basically is that we've queried, or the Times workflow has queried AWS, and it's returned a list of instances in here. So these are all of my demo instances from AWS. If I come in here to my AWS environment, these are all of the stopped instances that I have. And what I'm going to do is choose one called Carol Test for my example today. So I go to my list, I choose Carol Test. That is the device I want to power on. I'm going to search by name. It will show me that it's stopped, shows me the instance ID, gives me the option as to how long I want this machine to be up and running. I have a relatively small task today. I'm just going to leave it running for 1 hour. If you don't want to get a Slack message, we've got the option to take that interaction as well. I'm going to take that option and I'm going to start the instance. So obviously, it takes a few seconds to fully spin up an EC2 instance in AWS. We don't want our end users kind of scratching their head, wondering what's going on. So we're going to pop up a little message saying, your instance is starting. All of this is dynamic based on the workflow within Times. It will eventually pop up and say that the instance is running. And what we'll also get then is a notification in Slack with the name of the device. As you can see, we've got our message here to our end user, and in our Slack environment, we can see we have an EC2 instance running, the instance ID, how long it will run for, 1 hour, and also the guy who's requested that instance. You'll notice as well, we've got a little stop button down here. More of that in a second. Okay, so I mentioned that we want to automatically shut down this instance after 1 hour. That was what I chose when I spun up the machine. How do we handle that type of logic within Times? Okay, let's jump back into our story and move across a little bit. So the next leg of this story is an event transformation that's running on a 20-minute schedule. So every 20 minutes, this event transform is going to run. And what this element of the story is doing is it's querying a resource. So something I didn't mention a few moments ago is when we spin up that instance, we add it to a resource. We add the instance name, the expiry date, the instance ID. And that resource is then queried in here to find the next resource that is about to expire. So this schedule would actually run 3 times before it said, okay, that instance, Carol Test, that you spun up is now due to be shut down. The hour is up. And it's going to pull out that instance from the resource, and it's going to go to AWS, and it's going to shut it down. So this part of the story is, first of all, checking, is that instance still running? Because it may have been shut down manually within AWS, unbeknownst to Times. So this part is, if the story is still running, go to AWS, change the status, and again, we're going to have the idea of a loop, because it will take a few moments, obviously, to shut down the EC2 instance. So we have our little loop going on in here. Once the status is stopped, we're going to update Slack once again, just saying instance has now been powered down. And that is how the automatic power down of our EC2 instance is handled. Next logical question, what happens if I finish with that particular EC2 instance, or what happens if I am the administrator and I see somebody has powered up an instance that I don't want them to power up? How easy is it for me to stop that or to shut it down? As I hinted before, using our stop button within Slack, we can shut that down manually as well. While automation is great, sometimes we need a little bit of a manual override also. So that is what is happening in the third leg of my story. Again, we're using a page in this case. This is a very basic page because all we really want to pass in to this leg of the story is the instance ID for that device, Carl test. We go through the workflow in here. We do a basic match to see if that instance ID is within one of our existing resources. If it is, once again, it goes through the stop procedure. It waits 2 seconds. It loops until the status of that machine is stopped, and then it updates that resource. It removes it from the resource, the list of instances we have running. So what I'm going to do is I'm going to stop this machine manually. Anytime we interact with Slack using a link like that, it basically gives us a thank you message. Thank you for interacting. And we can then see within Slack that EC2 instance has been manually closed. It has the dude that's done it. It has the device, the instance ID, etc. So the loop is closed. Our instance has been shut down. And you can see again, as the events, JSON events pass through the actions, we have a little number that represents, as I mentioned earlier, the events, and we can query those events and the JSON payload within those events at any point. Okay, cool. So that is the webinar. What we might do next is take a couple of questions. So if you do have any questions on anything that you've seen in the webinar this afternoon, please drop them into the LinkedIn event that you would have got. We can handle those. A couple of questions already came in. So firstly, how does Tines interact with Prowler? So the short answer is that we don't have any pre-built integrations, even though we don't like the term integrations, because an integration to me kind of has ideas of something I need to build, something I need to maintain. We prefer the term templates within Tines. And within the platform at the moment, we have over 5,000 pre-built templates for lots of different types of applications, including AWS. Do we have an integration with Prowler right now? No, we don't. But they are incredibly easy to build. As you would have seen, we can use a blank HTTP request, and we can simply put in the API endpoint if we know the endpoint that we want to query. We can also use curl to Tines. So if you have an application with a well-documented API, you may see curl commands as example pieces of code within the documentation. Within Tines, all you would then need to do is copy those curl commands and paste them in to your Tines workflow, and it actually builds an action item for you. So it gives you somewhere to get started. As regards Prowler specifically, what you could also do is you could forward Prowler events into AWS Security Hub, and then you could ingest those events into a Tines workflow. So there's many different ways of approaching that specific use case. Even if we don't have a pre-built template, you can look at other ways of ingesting the information into the workflow. The next question we had was as regards the AWS IAM story. The question was around, could we leverage that story for Okta SSO? The particular use case that I looked at, yes and no, is the short answer, in that you could certainly use the logic that's in that story, you would most likely have to change the API endpoints that you want to hit. But you could certainly use that logic as a starter. And that again goes to our Tines story library that has over 500 pre-built workflows that allow you a warm start with the platform. So if you go to tines.io and look for story library, you'll see the 2 stories that we would have covered off today, and you can import those stories and get editing them incredibly quickly. Another question we have is as regards, is Tines a hosted, a SaaS-based solution only? Short answer is no. We've got multiple different ways of using Tines. We can obviously offer software as a solution. You log into your Tines website or your Tines tenant like you would any other website, which will be stored in AWS in our EU West instance in Dublin. We can go on-prem, so if you want to self-host Tines, you can certainly do that. Or we also have a hybrid model, which basically is the SaaS version of Tines with the Tines tunnel associated with it. That's an encrypted tunnel, a reverse SSL tunnel that basically allows you encrypted communication from your on-premise solutions, such as on-premise Jira, for example, securely back into your cloud instance of Tines. So there's multiple different flavors of Tines depending on your specific requirements. So I think that is all of the questions that we have today. Let me just give one last check and I will just verify. And a great question actually in the chat there around the number of tickets that you can create. So what you could potentially, you'll mention on, or you'll remember that I mentioned on the demo or on the webinar that I wanted to limit the number of tickets that I created. I specifically said something like 5 because I didn't want to create 1 million tickets. What you can also do is you can create 1 ticket and you can introduce logic, just add comments onto that ticket. So again, a particular use case might be if we're ingesting an IOC, for example, and we've already created a ticket within the last 3 days for that particular IOC or for that particular alert, don't create a separate ticket, simply add that as a comment to the existing ticket that's being created. So again, there are use cases or pre-built stories that have that exact functionality built in, but great question. Okay, and if there are no further questions, thank you all so much for your time and attention today. As I said, if you want to take a trial of Tines, please go to tines.io and sign up for our community edition. That's free for life. Go to the story library and look at the stories that we've pre-built for you. Import them to your tenant, get playing with the platform, and I wish you the best of luck.